Okay, here we go. Welcome to Linear Graphs, flipped lesson number 5. So let's look at this story about Ruby. Ruby used her house as a cat shelter. She let it get out of hand and ended up with 80 cats. So she had 80 cats, and then what happened? Well, she decided to find them good homes, and she gave away 5 cats per week. So that's a story using words, but we can use a graph to tell the same story. So go ahead and look at the graph about Ruby's story. We noticed a few things. We noticed that we've got the y-axis labeled number of cats. We notice the x-axis is labeled weeks. We notice we have an 80. And we notice we have a 16. So we're going to use what we notice. Oh, we also notice that the line is decreasing, right? So we're going to look at all these parts of this graph and we're going to analyze it. So when we analyze it, we're going to be looking at some specific things. What's the y-intercept? We identified it's 80. So here's my y-axis, and the y-intercept is 80. So what does the y-intercept mean? Well, if we go back to the word problem, looking at the words, we notice that after she let this whole cat shelter thing gets out of hand, she ended up with 80 cats. So that's part 1 of the story. Part 2 of the story says, okay, now she has 80 cats. Then what happened? So when we're looking at what the y-intercept means, it actually means in the beginning she had 80 cats. And because there's 2 parts that might seem a little confusing, you're like, no, in the beginning, Miss Overby, she had no cats. Okay. After she was done collecting cats as a cat shelter in her house, she had 80. And then, so we're going to say she had 80 cats in the beginning. When she started to give them away. So whatever I'm writing down, you need to write down. She had 80 cats in the beginning when she started to give them away. Okay, so what we're going to do is we're going to look at the x-intercept. And so the x-intercept right here is 16. And so we're going to write that down, and then we're going to ask us, what does the 16 stand for? What does that x-intercept mean? So we really have to look at the graph and understand what's going on. We notice that the line is decreasing, and that makes sense, right? Because with each passing week, as the weeks go on, there are going to be less and less cats, right? And so finally, there are less and less and less and less cats until finally, what happens? On the 16th week, how many cats are left? 0, that's right. So we'll say something like, on the 16th week, there were no more cats to give away. All of them were gone, right? No more cats to give away. So what we're trying to notice here is that in a word problem, when we graph it, the y-intercept and the x-intercept are going to be a very important part of what's happening in the story. So let's look. I know you guys didn't know that Mr. Matcher and I do an annual push-up competition, but we do. And right now, Mr. Matcher is way ahead of me. He can already do 20 push-ups, and he has plans to increase the amount he can do by 5 push-ups a week. And I want you to write in that box on your sheet, I want you to write y equals 5x plus 20 because that explains in equation form all of these words. And then there's me. I can only do 5 push-ups, but I hired a personal trainer this time so I can increase the amount I can do by 10 push-ups a week. I didn't like losing to Mr. Matcher last year, and I am super motivated. And so what I want you to do is I want you to write in that box y equals 10x plus 5, because that equation represents all of the words that describes my story about push-ups. All right, so we are used to, when we see an equation, we're used to graphing, right? If I saw this, wouldn't I quickly go, find 20, oh my goodness, so it'd be way up there, and then I put a dot, and I'd go up 5 over 1, and shoop, and I'd be done, right? But no, When we're in a word problem, there's a lot more involved. First of all, you'll notice in a word problem, we only have part of the graph, right? Normally, our graph goes this way and this way, but we're only using the first quadrant because in the first quadrant, both the x and the y are positive. And in most word problems, we're just going to be looking at the positive parts. I can't do negative push-ups, right? And weeks can't be negative weeks. So that's why we're just in the first quadrant. So the next thing before we graph, when we're in a word problem, is we have to label our axes, right? We've got to say, well, what's the y-axis going to stand for, right? That's the y and that's the x. We go back to the word problem, and I have two choices, right? I've got push-ups going on, and I've got weeks going on. Now I'm going to tell you something. The x-axis is always for the things that are independent. So which is independent, time or push-ups? And I'm going to tell you something. Time waits for no one, right? Time's pretty darn independent. No matter what we do, time keeps ticking. Push-ups, on the other hand, are dependent on whether we get down on the floor and do them, right? So push-ups are going to be dependent. Time's going to be independent. So we're going to write our word week on the x-axis because that's our weeks. We're going to keep track of how many weeks there are and how many push-ups. Push-ups are going to be our dependent label, and that's going to go on the y-axis. Now, we've got one more thing to do before we jump in and start graphing. And what we've got to do, let me check on this. What we've got to do is decide how to label our numbers. For weeks, we don't have a problem. We can use, well, we start out at 0 weeks, right? And then 1 week, 2 weeks, 3 weeks, 4 weeks. I don't think Mr. Matcher and I are going to train like super hard for like more than 11 weeks. So we'll stop there. And so with push-ups, though, we've got to look at the push-ups and we say, Mr. Matcher can already do 20 push-ups. So I can't take my y-axis and start labeling it 1, 2, 3, right? That's not going to make sense. I'm not going to have room to reach 20, and I'm not going to have room for him to even increase past 20. So we're going to decide, instead of going up by ones, we're going to go up by fives. So we'll have 5, 10, 15, 20. So plenty of room for us to graph not only, 25, 30. So plenty of room for us to graph not only where he's starting, but we can still have the numbers left for him to improve, right? So here we go. We see that our y-intercept is 20. So we're going to find there's our y-axis, there's the 20, there we start. And so our slope is 5. That means every week, Mr. Matcher does 5 more push-ups. So that means when we go from 20, we're going to rise up 5 over 1. That makes sense, right? Week 1, he's going to be able to do 25 push-ups. Let me get rid of those lines. Okay. And same thing, rise up 5 over 1, up 5 over 1. We're going to keep going so we get some idea of where Mr. Matcher will be as the weeks progress, right? Like if you wanted to know, hey, where's Mr. Matcher at 5 weeks? Wow, he's already up to 45 push-ups, right? All right, so let's go ahead and make my chart. We're going to do the same idea where we're going to put weeks down here to label the x-axis because time, whenever we're dealing with time, that's always going to be in our independent variable, and x is our independent variable. So here we go, push-ups. So this represents how many push-ups. And I'm going to do the same thing so we can compare our graphs, right? I'm going to go up by 5s. So everything I'm doing, you guys are going to do as well. And let's do our weeks. We're going to keep the weeks like this. Is it okay to be jumping? Our weeks are only going up by 1 each time, and our push-ups are jumping by 5s. Is that okay? Absolutely. You'll see it all the time when you look at graphs. So let's go ahead and graph my situation. In the beginning, my y-intercept was 5 because that's how many I could do. But every week, I'm going to increase by 10 push-ups. So here I go. Up 10. Oh, I've got to go up 2 over 1, right? If I want to do 10, I have to go up to 10, up to 15, and then over. So that's something you have to get used to, right? I'm not going to go up 10 like 10 times, 1, 2, 3, 4, 5. I'm just jumping up 10. 5 plus 10 is 15 over 1. 15 plus 10 is 25 over 1. 25 plus 10 is 35. Oops. 35, and then over 1. And then we have 45 over 1. What do you guys notice? Let's check out what's going on by the 4th week. By the 4th week, I can do 45 push-ups. How many can Mr. Matchner do? He can only do 40. When was our competition? Did it say? Let's see when our competition is. Oh, it didn't say. It's upcoming, but I know I'm hoping that the push-up competition is in 4 weeks because I'm going to be able to beat Mr. Matchner in 4 weeks. All right, why do we do that? Because using a graph to tell the story helps us to predict and to see what's happening down the road. So when we are looking at word problems and we're getting ready for the test, we're going to be looking at specific types of problems that give us information in words and an equation, just like we saw with me and Mr. Matchner in our push-ups. And then we're going to do the graph, just like we just did with the push-ups. So here we go, Enrico, and I picked Enrico because that's my dad's name. My dad immigrated from Italy, and and he first learned how to speak English when he went to kindergarten. He did not know how to speak English. But he ended up being an administrator in the Dade County Schools administration department, and he could also make some beautiful furniture for myself and my 4 sisters. So there we go. We got some background about my dad, Enrico. So he wants to start a handcrafted furniture company. The supplies he needs to start the company will cost him $3,000. He will also rent a studio for his work at $1,000 a month. The equation that represents the cost for Enrico's company is, there we go. All right, so we're going to label a number each graph before, each axis before graphing. So what's independent again? Time is independent. So here we go. The only time I see is month. So I'm going to say the x-axis represents the months. Now, even though Enrico is a real person and he really does make furniture on the side as a hobby, he is really not starting his own company. He is well into retirement. All right, so let's see. Let's look at the y-axis. And the y-axis is going to be about the money that he makes, right? So he's going to try to make money. So we'll call this, we'll just put money. We're going to call it revenue in just a second. Okay, so what's the y-intercept? Well, we've got to graph it. Oh, we can't graph until we number these axes. All right, if I'm going to go all the way up to 3,000 for my y-intercept, I am not going to be counting 1, 2, 3, 4. I'm probably going to say 1,000, 2,000, 3,000. Let me move my title over a little bit. Right? 4,000. That's what I'm going to do. Okay, and then months, we're not going to have a problem with months, so we can go ahead and say 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go ahead and graph this. My y-intercept is 3,000, so we'll go up to 3,000 and put our dot. And our slope is 1,000. So that means we're going up 1,000 over 1, up 1,000 over 1, up 1,000 over 1, up 1,000 over 1. So we're going to go ahead and shoo. There we go. All right, so what's the y-intercept? The y-intercept is 3,000. And what does it mean? Well, it means that in the beginning, he needs to spend $3,000 on supplies. So we're going to say in the beginning, you can say at the start, in the beginning, he needed to spend $3,000 for supplies. Oops. For supplies. Okay, and then it asks what's the x-intercept. So this is interesting. I don't see that it has an x-intercept, right? And why is that? Think about it. When he first started this company, he had to spend $3,000 just to get going with the supplies. And every month, the cost, and so really instead of money, we should probably put cost. The cost of running the company continues to climb. It's not going to go down, right? So there is no y-intercept. So what is the y-intercept? We're going to say not applicable. And we don't have to answer this next one. Sometimes there'll be an x-intercept, like in our push-up competition. Sometimes there's not. So let's look at the second part. Let's say that Enrico has made enough mid-century modern benches to start selling them on his website. So we're going to make a different graph this time. The first was the money it took to get his company running. The second is going to be the money that he's going to make, right? So he prices them at $500 a piece, and the equation that represents his revenue is y equals 500x. I can't help but notice, but there's something missing in this equation, and it's my y-intercept. So I'm going to go ahead and put it in. I'm going to go and I'm going to label. Once again, my y-axis is going to be the money. This time, instead of cost, we're going to call it revenue. Do I use the word revenue anywhere? How much revenue? So revenue doesn't mean profit, but revenue means the money that's coming in once a company starts selling something. So profit would be, right, you take your revenue, you subtract your cost, and there's your profit. So we're going to look at revenue, and we started out with 500. So we're going to go ahead and go up. Why don't we go up by 100? Does that sound good? Actually, let's see. If we go up by 100, that's not going to work. Let's go up by 500. So we'll go 500, 1,000, 1,500, 2,000, etc. I'm going to have to move my 2,500, 3,000. Okay. And then let's do, okay, so he prices them at 500 a piece. Okay, so amount of furniture. So we'll just put, it's a bench, right? So benches. So these are benches sold, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we go. Let's graph. So it says that the y-intercept is 0. So we're going to put a dot here. And then it says the slope is 500. So that means for every bench sold, he makes $500. So that's up 500 over 1. Up 500 over 1. Does this make sense? Like if he sells 3 benches, there's $1,500 that has come in, the revenue. Up 500 over 1. We can continue to do this. Okay. So there we go. All right, so what's the y-intercept? The y-intercept is actually 0. Because you know what? In the beginning, he has made $0. $0. Okay, how much revenue does Enrico have after selling 6 benches? Well, let's just look at our graph. So 6 benches matches up with $3,000. Okay, so what we're going to be doing in class is looking at lots of words and turning them into graphs. And this is the last section in our test. And once we get really accomplished at this, we are going to practice graphing again and take our test. So bring your notes to class, and thank you for joining me.